In this video, I would like to find the derivative of the absolute value function. Well, the absolute value function is easy to graph, and I think a picture here is going to help a lot. The absolute value function, of course, just two lines, right, making that V shape. And I know something about the derivative of lines. And so I'm going to let this be y equals the absolute value of x, taking the derivative of y with respect to x. The derivative of a line should be its slope. And so over here, where x is bigger than 1, I see a rise of 1 and a run of 1. The slope's 1. When x is less than 0, and that's a linear function, 2 down 1 over 1, the slope is minus 1. So when x is less than 0, I know the derivative. When x is more than 0, I know the derivative. And so now my question is, what is the derivative of this function when x equals 0? And so I want to know the derivative of y with respect to x when x equals 0. All right, well, let's see. Let's go back to kind of our original idea of derivatives, right? So f of x is the absolute value of x. And I want to know f prime of 0. So if I go back to my definition of the derivative at a point from section 3.1, I would get this. The derivative is the limit as h approaches 0 of a, which is 0, plus h, in absolute value, because that's what my function says, minus the absolute value of a, all over h. And so here, I would have this limit, right? The limit as h approaches 0 of the absolute value of h over h. Well, let's think in terms of limits. For this limit to exist, the two-sided limits, the one-sided limits would have to be the same. So instead of evaluating this limit, let's think about the limit as h approaches 0 from the left-hand side and the limit as h approaches 0 from the right-hand side. Well, when I get close to 0 from the left-hand side, that means h is a negative number. So the bottom is negative, but the top is positive, which tells me that must be going to minus 1, right? Because the only difference between these two numbers is the sign, the sign. All right, the limit is h approaches 0 from the right-hand side. Well, if I'm approaching 0 from the right-hand side, that means h is positive. And I'll get positive 1. Well, if my one-sided limits are different, then my two-sided limit does not exist. Okay, the derivative of a function is the limit of the difference quotient provided that limit exists. Well, this one doesn't. The absolute value function doesn't have a derivative at the origin. And in fact, I could say that this value is the derivative as we are approaching from the left, and this one is as we're approaching from the right. And because they're different, I don't have a derivative there. So this is my final answer. The absolute value of x has no derivative at x equals 0. We'll talk more about where derivatives don't exist in a future video. In our next video, we're going to talk more about these limits, not these particular, but one-sided derivatives.